Okay. So, welcome to our third class of the Python course in our data analytics bootcamp. It's amazing that we've gotten this far, and I hope you're having a good time. Tonight, I've got such an exciting class for you. We're going to be doing something called market basket analysis. And I think many of you will um, understand this theory because of you shop, right? You shop in different stores, whether it's online or in a grocery store or in a local store that you enjoy. And so I think the gist of the market basket analysis will make a lot of sense to you. And of course, I will be in a minute going over the lecture notes and walking you through the concepts behind it so that you understand once we go into code. So that being said, you do want to make sure that you have access to the Open Hub resources. Again, this class is the Market Basket Analysis class. So when you go to Open Hub, you want to make sure you're just in the right area. The data set that we're going to be working with tonight is going to be um, it is called groceries data set. How appropriate, right? It is the groceries data set. And of course, the lecture notes is class 3 lecture notes. Okay. And for anyone who just joined Zoom, of course, add your name to your to the chat so that we have you logged in as being present. Okay. And here comes Walker. Wonderful, wonderful. So for any of you that just joined, just make sure that you have access to the resources on Open Hub. This is class 3. You want to download the groceries data set and also class 3 lecture notes. This way you can follow along, as I'm talking, but you'll have those resources at your disposal too. So, one of the things I love to start class out with is just congratulating you all for pushing yourselves to learn more. This is not easy subject to learn, but it is something that you can do, and you all are doing very very well. And I want to encourage you to attend office hours when you find yourself getting stuck or you need help or you're not sure. We have wonderful people to help you. So reach out to office hours, on site, find out what the hours are, and any other learning opportunities that you could avail yourself to. As Yulia mentioned earlier, there is an opportunity for internship. And so if you are interested, there will be a form that is provided to, fill out and convey your interest in the internship. Ironically, it's involving data and data science. How cool is that? And so I would just want to say to you that these types of opportunities are excellent resume builders. They're great for boosting your confidence. They're great for pushing yourself to the next level. So whatever you do, don't say, "Well, I would not be able to do that." Look at it the opposite way. So I have some understanding. I have some skills. I'm going to try. And remember that interns are not expected to be uber gods in the knowledge area. They are in training, they are learning, right? So the understanding is that you're not necessarily an expert, but you're willing to learn, and that's what's really important. The other thing that's important is getting contacts with certain employers that are looking for staff in the area that you're interested in. Those connections are very valuable for establishing getting a job in that particular area. So it's invaluable. Okay, so enough of my spiel, right? Enough of my spiel. All right, we have another student coming in. Renita is coming in. Good, good, good. So it's good I waited a minute and gave you my spiel because I knew people would be a little bit late. All right, so just a reminder, make sure you sign in on the attendance. Make sure you download the resources from Open Hub. Right now, we're just worried about the groceries data set and the class 3 lecture notes. I'm going to go ahead and get started with the lecture part because that's very important. One of the many important things. Because if you don't understand what it is we're doing, none of what we do makes sense. Okay, so that's something that's super, super important. All right, let me go into presentation mode. All right, here we go. And I'm going to turn off the subtitles. Okay. All right, so we're going to talk about, and let me just make sure those subtitles are turned off. It's just easier. Okay, I think there we go. I apologize. All right, so tonight it's market basket analysis. Now, I did talk a little bit about it this last week. I mentioned it just very quick at the end of class, so you probably don't even remember it, and that's okay. But before I actually go into the slide, think of it this way. You shop. I know all of you shop. Someone has to shop, right, in this class. Whether you go to the grocery store, the convenience store, you go to Amazon online, you shop. And when you shop, you put things in your basket or in your cart and you check out and pay and go along your merry way. Well, over time, many retailers and people in the industry want to know what types of items get combined with other items. In other words, how often do customers put this and that in their basket? Is this a common thing or not? And the reason for this wanting to know is it will inform their decision making. We'll talk a little bit more about the specifics of the decision making, but I think this will resonate with you because you all, I'm sure, have shopped. All right. So we're talking data science and we've been doing machine learning. So we've done supervised machine learning in that we provided it the algorithm or the model a data set and said, learn from this data set. Well, in this case, we are not doing that. We are doing an unsupervised machine learning technique. So we're not training a data set or predicting an outcome. We're looking at relationships between things. And so we're not predicting, we're looking at the strength of the relationship. This almost sounds like some of the things we've talked about. Is this statistically significant, right? I've mentioned that several times. Well, this is in that same realm. So the algorithm that we are using identifies relationships between items, but also combinations of items. So think milk and bread and fruit and milk and fruit, right? That there's pairs of items and what things have a relationship with each other, meaning they're frequently purchased together. So the results of this type of analysis helps marketers determine what product combinations people purchase when they shop. What's really important is that informs where they put those products in the store, right? So if you frequently buy two products together, it would be so much nicer to have it in the same aisle or in the same end cap or in the same area so that you can pick this and that, put it in your basket and go along your way, right? So that's something that's very important. Um, yes. So Connor asked this question. This is like they frequently bought together recommendations. You got it, Connor. A plus. Excellent. You took the words out of my mouth. So that is exactly right. So we all are probably familiar with Amazon making recommendations. Oh, you bought that, and other customers that bought that also bought this. Right. So it's that same recommendation. This informs that recommendation process. Exactly. Now, let's put it in those terms, and I'm glad you mentioned that. So if two items are very rarely put together, it just so happens that, you bought two items and another person bought another item with one of the items that you bought. Do you want to get notifications all the time of those recommendations? No, you want the good ones, right? So for example, you buy a TV, but you don't know what stand you need with the TV. Wouldn't it be nice if it recommended the right one with your TV, right? This way you don't have to go searching. So a lot of times what Amazon does is they make suggestions that logically combine with what, and they actually help you. Here's the cable that you need for that printer that you bought, or here is the paintbrush for this particular type of paint, right? So there's those recommendations as well, which is a value add for the customer and for Amazon because you might not know and they're helping you and guiding you. And in some cases, they'll bundle it into a very affordable bundle price, which makes it better for you because the cost of the total purchase goes down. So all of that is informed by market basket analysis. Okay, so the important concept to take away from this slide is that there are going to be, when you look at a data set, there's going to be hidden correlations that you cannot see with the naked eye. You can, and think of it this way, you're trying to put pairs of items together over time, and how are you going to be able to go through all of that spaghetti, right? All of that mess. It's very difficult to see those. And if anything, you might be able to see one or two, but the strength can't be determined. So that's why we do market basket analysis, because we need the machine to tell us and aggregate the data together in a logical way so that we can look at it and say, that's statistically significant. This one's not meaningful. So we're not going to focus on it. All right. So let's go to the next slide. So I'm going to talk about the a priori algorithm. Now, it sounds really mysterious, but it's very simple. We're looking to look at items or item sets, things that are purchased together, and subsets of frequently purchased items. So that's what, if you think about it, it's an association. This is logically associated with that. Milk is associated with bread or milk and eggs, right? There's a big, there's a big, we'll call it, it's well, there's an association between beer and diapers, okay? And so this is a common, we'll call it a joke or a ha-ha in data science, but the beer and the diapers scenario, when you send someone to the store to get beer, they may pick up diapers, it's likely. Now, it's just something that has been observed over time. And so that's one of those things. But the goal is to determine the association, right? And predict the likelihood of the products being purchased together by literally counting how many times they're purchased together. So the frequency is what drives it. If it only happens one time that someone put, eggs and milk together, well, it's not really, something to shout home about, right? But if hundreds of people are doing it, now your frequency has gone up. So when we think of frequency, it's not your frequency, it's everybody's frequency. So everyone that shops online at Amazon, they're looking at all cases where, customers all over the world bought this and that together, this and that. And so that frequency looks at a massive amount of data. Now, that being said, if you're looking at a data set that has not a lot of mass to it, not a lot of volume, not a lot of unique shoppers, well, your ability to associate goes down because statistically there's less of those pairings of items, right? And if you get a result, because the data set is small, just like anything we do in data science, it is going to be very hard to generalize and say this will always work this way. In other words, it's always the case that milk and eggs go together. If you only had 100 people that did it, that really doesn't matter in the scheme of things. It's when you have lots of people, large data sets. So that's just something I want to throw out there. Now, there are three metrics or components that we care about when we talk about this algorithm: support, lift, and confidence. And I will tell you that these metrics can be applied to different aspects of the algorithm. Okay. So, for example, if I were to say, if I buy eggs, I will buy milk, right? It's an if then statement, just like in programming. Well, I can determine the support, lift, and confidence for that statement. If I buy eggs, I get milk, or vice versa, right? So there is an if then, but they're also looking at, well, if I buy milk and I also buy eggs, what happens if I buy eggs? Do I automatically buy milk? In other words, does the direction go in another way? And you can look at the support, lift, and confidence of that. Okay. So the idea is that these metrics can be used in a multitude of ways. I'm going to show you tonight an example in here in the PowerPoint that keeps it simple for you as you're learning. But I don't want you to think that that's all there is. There's so many ways you can apply this, and it gets really fun and scary at the same time. All right. So I don't want you to think, oh, well, that seems limited. No, it's scary, not limited. So these metrics look at relevance and popularity of each item combination. And I think you can kind of gather that there's so many combinations and possibilities. You could look at combinations of 3 and 4 items. Like we're focusing on pairs, but I mean, you could start combining in so many different ways. The bigger the product catalog, the scarier it gets, right? So, some of the popular applications of this algorithm are forest departments. If let's say they want to understand the intensity and probability of forest fires. So in this case, they're looking at conditions and weather conditions. If I have this condition and that, what is the likelihood of a forest fire? So think of it, I'm not shopping. I'm looking at two variables that basically exist together. One leads into the other, and there may be an association. So I could use this algorithm for that. That's a case in point that there's so many ways this applies. Another one, used by Google and other search engines for their autocomplete. So if someone types this, is it likely they mean that? Right? And so it tries to autocomplete to make our lives easier. Now we all know sometimes it gets it wrong, right? So that's an example where they don't have enough data. It's trying, but maybe it needs more data. Here's another one: the healthcare department to analyze the patient database and predict which patients might develop blood pressure, diabetes, and other common disease. That should sound familiar to you because we did that. Now you might be wondering, well, wait a minute, we didn't use an algorithm like this. We did machine learning. We did logistic regression. We did, but guess what? It's an association between symptoms and measurements, right? So the blood pressure and the diabetes, does it lead to something else? Is there an association? So it's that same ideology. Another way of using it is to categorize students based on their specialties and performance so that we can improve academic performance. So, you might, maybe someone might come to you and say, you seem to do well on this subject and that subject. Maybe this should be your major, in college or something along those lines. So that's the whole idea between, looking at associations between what you're good at and maybe future outcomes and things like that. And then, of course, last, as Connor mentioned, e-commerce websites, using it as a recommendation system. And again, the whole idea is to provide a better user experience. And we all like that, right? At the end of the day. So let's look at an example of 4 baskets. These are rudimentary baskets, but they have items that I think you'll know what they are. So we have in basket 1, we have milk, beer, eggs, bread, bananas, and apples, right? Now, looking at this here, bananas and apples cannot be found. They're zeros, right? This is a one hot encoded data set. So in basket 1, they've got the 4. They've got milk, beer, eggs, and bread, but no bananas, no apples, right? Basket 2 has milk, no beer, no eggs. They have bread and nothing here. Basket 3 has milk. Gee, milk is very popular, it appears, right? No beer, no eggs, but they have bread, and no bananas, but they do have apples. And basket 4 is no milk, no beer, no eggs, but they have bread, and bananas and apples. So you start to see something jump out at you. Now, this is just 4 baskets, but we see bread is very popular. That's an easy, we can just eyeball this and say bread is pretty popular. So using this very simple set, we can actually apply the formulas for the metrics that I spoke about earlier. So let me show you how that works. So support, what is the overall popularity of the product? Okay, so you're looking at support of an items. And the way that you do it is you take the transactions that contain the item and divide it by total transactions. So for milk, and I'm going to jump back, for milk, we have three transactions that had milk, 3 out of 4. So that's going to be 75% support. So milk is present in 75% of all purchases, and that's in our data set. It's very careful that we remember that we're just talking about our current data set. Okay. All right. Let's see if someone has a question here. Um,
It's not a question, sorry.
Okay. Okay. No worries. No worries. All right. Sorry about that. So one of the things to remember is that we're determining the percentage. Remember, we were talking about frequency. Now, bread has 100% support because it present in all purchases. So 100% support means that, well, bread is pretty popular because it's prevalent. It has high frequency. So high support means that the item's popular and marketers should pay attention to it as an item. So anything that has high support is something to check off as, all right, we need to look into this deeper. Okay. All right. Next one is going to be confidence. So confidence is what is the likelihood of different item combinations of purchases. So if I look at bread and milk, now you notice how bread has an arrow after it and then milk. And what we're basically saying is if bread, then milk, which is like an if then statement. If bread, then milk. So the transactions with bread and milk divided over the transactions with bread is going to give us the confidence. So again, we have 3 and 4. The transactions with bread and milk, there's only 3 of them. And going back to my, right? So we're looking at bread and milk. So there's only 3 of them, right? These 3 and these 3. Okay. And so the transactions with bread and milk over the transactions with bread, which was all 4, that gives us 75. All right. So 75% of customers who purchased bread also bought milk. Now, these types of statements or conclusions are very easy for us to think about in our minds. And yet we're talking about a very, complex metric called confidence. But that's basically, if you think of it in terms of what does it mean, it actually makes sense. You might actually say that to someone. If they said, well, how many did they buy? Well, you could articulate that. So then we come to something called lift. That's the third metric. Lift is what the increase in ratio of the sale of milk when bread is also sought or bought. So basically, it's like an upsell if you think about it, right? So for those that bought milk, how many times or to what extent does bread also come into the picture? Okay. And so lift is the support of bread, all right, and milk, bread into milk, or if bread, then milk, the support of that, which we all already determined, over or is equal to, I'm sorry, support of bread, which is 1, divided by the support of milk, which is 0.75. So it's actually 1.3. So what this means in layman's terms is customers are 1.3 times more likely to buy milk if you also sell bread. So let me ask everyone, if you're a market owner, or you work for a market and you're trying to figure out how to put things together, um, what other types of things does this mean? So if you know that customers are more likely to buy milk if you also sell bread, what would you do? What decision would you make? How would you change a store? And if you're on Zoom and you want to open your mic, you can do that. So let me ask this question. If okay, good. We've got someone in the chat here. All right, you would also sell butter. There you go. There you go. Especially since, butter comes from milk, right? But that's a good point. So you may consider butter. So that would, what you're basically saying, Walker, is you would do additional analysis. Say, I wonder about butter, right? Excellent, excellent. What's something else you might do?
The bread aisle next to the dairy aisle.
There you go. There you go. Close proximity. And that would actually even solve the butter situation too, right? So that's, again, convenient. What else? Yes.
But if you put the two together in the next aisles, there is no opportunity for the customer to see something else while they're looking.
Ah, yes. So, and that's a good point. So you have to be really careful. So we want to, and I love the fact that you mentioned that, because you can't think linear in your thought process. You need to look at everything. And that might involve additional study on the products that are closer in those aisles to what you're proposing scenario wise. So there's a lot of things to consider. There's also things like, is it even logistically possible, right? So we know that bread or milk and butter and things like that, it has to be in a cooler case. Bread does not, right? So that might be a logistical consideration. However, let's say you couldn't accomplish it in close proximity, you might place coupons. So let's say I can't change my store, but I know that people that buy milk, you know, they're more likely to buy it if I also sell bread. So why not put a coupon next to the bread aisle and the milk aisle, so that if they buy the milk, they can get a discount on bread or vice versa, right? So now you're still taking advantage of that association that you determined, and you're helping the customer, even though there's other things you can't do, right? So those are things, you know, it encourages that pattern, and it also allows you to test other products with that combination, right? Like butter, like Walker said, butter. So great point. All right. So now we're going to go to the steps in the market basket. Now, what's really interesting is the steps are not really difficult. But I do want to, we're going to look at our data set tonight, and I'm going to share with you that your homework data set is a lot bigger. And there's a reason for that. And I'll talk about what the homework requires at the end, but the more items you have in your data set, the more rich it is, right? And I wanted you to compare the performance of what you do with a smaller data set like we're going to do in class tonight, and a larger data set that you're going to use in homework, okay? Both of these data sets are used for classes like we're doing. So they're available under, you know, Creative Commons, and they're commonly used. So just so you know, they're normed around what you need to do with them. The key is you understanding how to set them up. And I'm going to show you how to do that. So first thing you have to do is acquire a transaction data set. Now, if you're asking, um, let's say you were asked to do an internship for a small store and they want to give you a data set. Well, after tonight, you should know whether or not that data set is usable for your purpose. All right. So that's why we're emphasizing acquiring a transaction data set. You then, of course, read in the data set, which we've done 1,000 times, right? Many times. And then you prepare your data set for market basket analysis. I'm going to show you the steps in a second, you know, code-wise on the screen. So just like other analyses, we have to do data pre-processing. We have to do that with this as well. There's things that we need to think about, and we need to set up the data in a way that makes sense for the algorithm. We then build the algorithm, and that's the a priori algorithm for market basket analysis, and then sort the results so that we can see support, confidence, and lift at the high. So we basically sort it so the high values float to the top, right? Because we know at some point there's going to be values that are not statistically meaningful. We don't want to look at those. We want to see the good stuff at the top, kind of like the cream and the butter. The cream rises to the top. Okay. So in our first step, of course, you know, downloading the data set tonight, we're going to be working with the groceries.csv data set. It's available on OpenHub. It has 38,765 rows, and it basically entails the purchases of people from grocery stores. So it's very much in line with something that you could relate with. We then read in the data set. Now, this is done no differently than we've been doing for this whole boot camp thus far. It's very important that you make sure you know the file extension of the data set. So for homework, the file extension is an XLSX file. So you want to just remember in your head, okay, it's a different type of file. What do I need to do differently? Okay. Now, in preparing the data for market basket analysis, this is your pre-processing. What you need to do is decide how you're going to group the items so that you can feed it into the algorithm, or the a priori algorithm. So you have to look at the data and say, what do we have that's the same? We have a member number, or let's say we have a customer ID, something that's unique, right? In other words, what makes it different? How can I say this basket versus that basket? Is it the customer ID? Is it the member number? Right? We can't use date because many baskets happen on a given date. So you want to look at your data set and say, what would be that unique basket? How could I differentiate between basket A and basket B? In this case, for tonight, it's going to be the member number. Okay. So the member number will be that, unique value. And what we're going to do is we're actually going to group it based on date and member number. Now, the theory is this. none of us are going to go through the grocery store more than once in a day. But if we do, we're going to account for that later on. So what this is basically going to do is basket and date, basket and date, basket and date. And every basket is unique based on member number, okay? And so we're going to create that grouping, and we're going to call it single transaction. We're going to actually add a column to our data frame, okay? We're going to call it single transaction. And it's going to be basically a value that would never repeat. Does that make sense to everyone? So if I have member number and date on a given day, that's never going to repeat, highly not likely. Now, if it does for some reason, then we can account for that later on, and we can get rid of that unusual circumstance, okay? And then what we're going to do is we're going to pivot the table so that we do a cross tabulation, very much like pivot tables in Excel. You did advanced Excel, you probably talked about pivot tables, did a little bit. Well, what we're going to do is pivot it so that our transactions look differently than they did originally. We're actually going to have each single transaction identified on the left, and the columns are going to be the item description. So we can see milk, eggs, butter, yada, yada, yada. All right, very much like our table that we created or that I showed you earlier, okay, with basket A, B, C. Does that make sense to everyone? So that will be on the left column, and the item descriptions will be on the top. The third thing we're going to do in step 3, which is this is continued portion of step 3, is we are going to look, and this is that weed out process I was telling you about. We're going to look at, first of all, we only want to see items that are purchased by a given individual on a given day, and we're looking at one time per individual. We don't want to double count, is what we're trying to do here. So we're going to write a little function that encodes things so that all values will have a 1 or a 0, and this will allow avoiding the double counting. So if I purchased at grocery store twice in a given day and I bought the same item, okay, that's not an issue. But if I went to the grocery store and I bought different items, it's basically going to differentiate, okay? So item frequency is what we're worried about. Okay, and this simple little function, you'll see how it works when we actually run it. Then we run the algorithm, and the algorithm, basically, the beauty of it is built into Python. We're going to bring in a new library that you haven't seen before, but this library knows what a frequent item set should look like. It knows what a priori is, and it also knows what association rules are. We don't have to do any work. We let the algorithm and the library work for us, okay? So we basically run this, and then what we will do is look at the results, and then we're going to interpret the results, okay? So again, we're using a library that understands how to do this. Now, to get all the cream to float to the top, remember I talked about that? We're going to sort it, and we're going to sort it in descending. Ascending equals false is the same as descending. So we're actually going to, sort it, and we're going to get the first 8 rows. All right. So market basket analysis is used to reveal associations between items based on being purchased together. Now, important, just because an association's found doesn't mean it's meaningful, right? That's, I think, out of everything you've learned in the boot camp thus far and continuing into the next courses, I want you to remember that. Just because we found results does not mean it's meaningful. The question is it statistically significant? Does it matter? Think of it from the business terms. You don't want to devote resources to something that really doesn't matter anyway. If it's not meaningful, I've wasted my money. Think of it in those terms. Now, the antecedents and consequence show the direction of the association. This is the if-then. So if milk, then eggs. The milk is the antecedent. What's after the then is the consequent. All right? If-then. And then, of course, our metrics are going to determine whether or not the association is meaningful. It'll allow us to visually see that. So any questions on that? Everyone's like, wow, I think I get it. Any questions? Does it make sense to some level?
Yeah.
Yeah. Okay. That's good. That is good. That's meaningful. That's meaningful. All right. So any questions about the application or what you can do with it? Anything that you want to ask? Because inquiring minds, it's good to have these discussions really quick. We can do that.
My only question is, how does a regular grocery store just like do this automatically without like asking you?
Excellent, excellent. So there are some stores. Now remember, to have fancy software that does this in real time would be expensive. To have the staff, remember, grocery stores are typically not going to have data scientists sitting there unless they're a big chain, right? So smaller stores are not going to have this done. They're probably going to outsource it to some kind of provider that does this. Larger stores will be able to afford to have data scientists on board, and of course they would take the data and send it to that department, and that department would do the work and then loop back to the manager and say your merchandising's problematic because we've determined that we have a problem, or you're doing a great job because your end caps are strategically balanced with the two products that everybody loves, and so on. So the idea is many stores are doing it. Where it gets problematic is smaller stores that don't have the resources, and that's where students like yourself that are just getting started out may offer your services to them and or do internships, and things of that nature. But yes, the idea that it is done is very, very likely.
Okay, and then quick follow-up. If you have a small store, I guess you could probably just get that if you used something like Square or some kind of
They
software to
don't do,
make your
yeah.
purchases,
They'll
because
give you your
otherwise,
data. They'll give you your data, but they're not going to do market basket analysis for you unless they
right.
offer a product. And I'm familiar with Square, unless they have a product that does, analysis of your data, which would be an ad upsell, and you would pay more for that, right? So the idea with those types like Square and such, they'll give you your data, you have access to it, but it's highly likely that you're going to have to outsource that analysis. Yeah.
And so you would take that data and then you would create a data dictionary or a data set
Yep.
on
Yep.
your own.
What you would do is use that data. You would verify that, yes, it is capable of giving me the transaction item sets that I need, which it likely is. And then you would actually run it through the same process we're going to do tonight. You're going to identify which columns are usable. You're going to put them through those steps, and then you're going to look at the results. So it's basically the classic transaction data set. You need uniqueness so that you can determine the item set at the basket level. So think the person at the basket is the basket. It's an individual. So usually it's customer ID, or it could be order ID, because one customer is going to have a unique order ID. So each order ID, you can make the inference that it is a customer behind the order. That's just how, you know what I mean? It's inherent to the process. So you would use that unique value and then the date. And then, of course, the items that were purchased in the basket. Yep.
Okay.
Yeah.
And it seems like, since the dawn of the store, our meat computers have been doing this.
Yes.
Like we know that if you're going to buy croissant when you buy coffee, right?
Right. Right. Based
But
on direct observation or limited data analysis, and it may not be statistically significant. Yeah.
I see. Right. And so we're trying to squeeze out an extra maybe 10% profit margin or something, maybe even more, but like, right, you said direct observation, you'd be able to tell, but then you're saying, well, every once in a while, someone buys this as well. So maybe we work that angle
Yeah.
more.
The danger with that though is you're using direct observation and you're looking at one-offs, right? So you're looking at outliers or potential outliers, and you're trying to use inference or your gut. And anytime you run a business with just your gut and not data driven, you're taking a huge risk. And the risk is that, you're using your gut, you're using your memory, which you might not remember exactly what was purchased with what. And there's like, oh, I'm going to buy this thing to make it better because I think this is the case. It's risk, 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 right? And so the whole idea is that you're using data to drive your decision making, because the insights you're getting from, even though you might also have direct observation, you're qualifying that and you're verifying that, yes, what I saw is correct, and here's the stats to prove it. Now, the other thing to remember is, let's say you need to change your store in a meaningful way. Well, the bank is going to loan you money because you want new, coolers or what have you. You're going to have to justify why you need that money. Well, if you have data to support it, you're more likely to get that loan, because you can show that this is a thing. It's not just my gut. It's not just my observation. I have data to support that this is high frequency and there's a need. And so they're likely to offer it because the return on that investment will be high. Yeah.
Okay, great.
Yep.
Thank you.
Yep. You're welcome. Excellent questions. Oh my goodness. That's wonderful. Wonderful. Anyone else have questions? That was fabulous. Yes, go ahead.
You say if the milk and the eggs 75%, but the eggs and the milk is 100%. Which one is more valid?
Ah, very
Because-
good. Excellent.
Because
Excellent.
the milk, everyone buys the milk, but not everyone buys the eggs.
That is true. However, if you have a high frequency of eggs to milk, right? So every time they buy eggs, they also buy milk. That directionality, since it's 100%, is very meaningful, because it's a sure thing going in the opposite direction, not necessarily the other direction. So combining them in the store, let's say in close proximity, is going to be a win-win in either direction, because you have a high percentage in this one direction and you have a high percentage in the other direction, and both of them are statistically meaningful. So in combination, it's a win. Does that make sense? Exactly, exactly. Connor said inelastic goods versus elastic goods. Thank you, Connor. Exactly. Yes. So does that make sense that you would look at the directionality in both directions? Now, that being said, let's say there's a weak association, and I'm going to show you, you can actually determine the strength in each direction. If, let's say, it's weak in one direction and strong in the other, then you factor that into your decision making, because then that may mean that you need to think about this differently and be strategic in a specific way, right? You may forego the directionality in one direction because the emphasis is on the other, which is stronger. So let's say that means that you forego investing in that other because it is not necessarily an added bonus, because it's already part and parcel of what you're already doing, if that makes sense. So it's almost like you're getting the leftovers, but they're good leftovers, but you're not going to focus on the leftovers. You're going to focus on the core and the core value, right? And so that actually helps you strengthen your decision making, because you can drill down and think through, instead of saying, I'm going to go, crazy on both sides because it looks like it's all good. Those generalizations are very dangerous. You know what I mean? And it could involve, purchasing equipment, or going in through, a marketing campaign that could be expensive, going out and printing coupons like crazy, and that costs money, only to find out that you didn't get any value add from that. You got the real value from looking at the one directionality relationship and focusing on that. And sure enough, you got some gravy benefit because of the nature of that relationship. So anything in the other direction is just added gravy. All right, makes sense. I'm making everyone hungry now. Added gravy, eggs, beer, wine. What are we doing? Right? Any other questions? These are awesome questions, by the way. This is fantastic. Fantastic. This is metacognition on steroids. Thinking about thinking and bread and eggs. All right. Any other
Oh,
questions?
quick
Yes.
question.
Yes.
So if you were thinking about opening a store, and so you don't have any access to data,
Ah,
data is expensive, right?
yes. Yes.
So how would you go about buying data, and are stores reluctant to sell, and how
I'm
does that work?
glad you mentioned that. So here's what you do. Given, if you're in retail, let's say groceries, there is in grocery retail as an industry, there are known data sets out there that are utilized per the industry. So the industry provides the data. And what they're doing is they're looking at a swath of all grocery stores and looking at the patterns and the trends. Now, that being said, your goal is to make sure that you're like one of those grocery stores. So, for example, mom and pop is not going to compare themselves to Supercenter, right? Because that's a different type of store. So, you would want to look the data sets that are like your store and absorb that. So you can get that from industry. And a lot of times industry will provide those raw data sets. They won't analyze them for you. You might see some in some trade journals and things like that. And maybe if you go to conferences, they might discuss, oh, eggs are always put with, it's just one of those things. Like, when I was a baker, there's certain things when we put out baked goods, you put this with that because people always buy that. So it's part of the domain knowledge that is part of that domain. So it's you start with that domain knowledge, and then you acquire any data to fill in any gaps in that knowledge, and then you start collecting your data. And then you say, okay, let's compare it to what the domain says, and then make adjustments as needed. And that's why domain knowledge is superbly important. Yeah.
Okay.
Yep.
So when you say industry, like are there like providers, or like would you, if you wanted, let's say, something very specific,
Mhm.
like a breakdown of a mom and pop hardware store,
Absolutely.
how should I set it up? What are the items? Who usually buys what with what?
Right. So there's merchandising. There's actually people out there that have done market studies on that type of store. So part of your domain knowledge would be to go to those people, those experts, and get information, do your research, right? And there may be data to support their claims, highly likely. And they may give you access to that data, or you might have to purchase, access to that data. It's part of your
Mm,
trade journal type of access. So you get access
okay.
to these data sets, you can then analyze them and then make good decisions in your business. So that's done every day of the week.
So it's fairly low hanging fruit as long as you're
Yep,
willing to find it. Okay.
absolutely, absolutely. The key is um, making sure that you are positioning yourself relevant to others like you, but at the same time differentiating yourself. So, and this is where it gets really important. Just because your mom and pop runs a specific way doesn't mean the other mom and pop, several miles over does. It's location, geography. There's a lot of factors, right? Just like when we were talking about the Airbnb, there's a lot of factors. New York City is going to be very different in Airbnb land to, let's say, something out in the country. So you want to always think of that, other factors that are environmental type of
Mm.
factors, and economic factors as well. Who's your client? Who's your market? What do you know about your constituents, your stakeholders? Should you even be selling X products? Because people are not able to even put them in the basket, right? Or they want to put them in the basket and you don't offer them. So therefore, there's subtractive analysis. Well, they could have put it in the basket, but I didn't have it. And what are the implications? And then if I'm looking to differentiate myself from another mom and pop, well, I have what they don't. Now you're changing the competition landscape. So now
Mhm.
it's likely they will, and you build promotions, you have coupons, you have bundles, buy one, get one, and you start building the likelihood they will buy those 2 items or 3 items or whatever. So it all works together. But the big picture is you don't want to make decisions without data because it's gut, and you don't want to do that. So,
Okay.
all right, awesome. All right, are we ready to get started? Everyone's downloaded the data set from Open Hub. It is groceries data set. I'm going to go ahead and share my screen. Let's see here. And if anyone needs access, please let folks know. This way you'll have that. We don't want anyone to be without access to the valuable things that they need. That would not be good, right? And let me, I'm on 2 screens here and my screens are being weird, which is not good. Okay, there we go. Because I got disconnected. Okay. All right, again, we are working with the groceries data set on Open Hub. So you want to make sure you download it, extract it like we have been. And you want to go into Google Colab and start a new notebook. You can call it what you like. I'm basically calling mine Market Basket Demo because that's what it is. I am going to get rid of this code cell because we don't start with code cells. We start with the problem statement. But before we even do that, we start with a section, right? So everyone has a new notebook started, and I hope I'm going to add a section. Okay. That section, of course, we always do the problem statement. And again, the whole idea is we need to know what it is we're doing. And what is nice is when you start following a methodology, it becomes easier because you're building that process, right? Okay. So I want to make sure I don't leave anyone behind. So has everyone gotten into their notebook, started it, put a new section in? It's your problem statement.
Working on it.
Okay, good, good. If anyone gets stuck, just holler, okay? I am going to put the problem statement up just so that you can get that in there. And this will give us a chance to wait for everybody. All right, awesome, awesome. The problem statement, by the way, is a small retailer, ironically, right, wants to determine what products his customers tend to purchase together. He plans on providing the findings from the analysis to his marketing staff to see if new strategies can be developed or if current product placement and pricing strategies are working well. So you can go in each direction. Is what I'm doing working, or do I need to be doing something differently? Or um, do I need to even think differently about what I've been doing because I don't have a strategy? Maybe I have, not a lot of groundwork laid and we want to determine where we're at. All right. After you put that in, we're going to put the next section, and you probably remember this because we've done this several times, but we always have to import our libraries. Again, I'm bolding these sections just so that you can see them better. All right, and if anyone gets stuck and needs me to slow down, just raise your hand either in the classroom, someone shout out to me because I can't necessarily see the classroom hands. I'm getting old, it's hard for me to see, but I can see a Zoom hand, that I can see. So there's 2 libraries we're going to be working with tonight that you have seen before. All right, Pandas and Matplotlib, but the MLExtend library you have not seen. Okay, and that's specific to market basket analysis. Now, I'm going to ask that you do type this one just so that you become familiar with this particular library. It's not a lot, and I know you can do it. Now, what's really nice is this library understands what frequent patterns are. It's designed for Market Basket. It has all the theory built in that we talked about, the association rules, the a priori, the frequency patterns. So you don't have to, tweak it to do what you need it to do. That's the beauty of using a library that knows how to specialize. Just like Pandas is a specialty library, Matplotlib, all of these libraries have a special, capability or set of capabilities. Once you type in the libraries, just make sure you run it and that you get the green check mark. And once you're good, why don't you just raise your hand on Zoom? So I know the Zoom folks are good. And then if there's a hand raised in the classroom, someone will halt me. Right, Bryant? What's really cool, by the way, while you're typing this is there's 4 lines of code and so much capability. That's what's very powerful about this. Provided your data set is capable, right? If you have no way of identifying a unique basket, that's an issue. That's why transaction data is so valuable in this industry. How are we doing? Is everyone good? Are we ready to go on to the next thing? Yeah? All right. We're going to upload our data set. So the way that you do that, remember, you've got this little folder at the bottom here. This is our files. We're going to upload it. Remember that we're clicking not on the black folder down here with the arrow, but we're clicking on the one above it. Okay. And we are looking for our groceries.csv file. Okay. Our groceries.csv file. Now, of course, we have to bring down a new code cell because, well, as you know, in order to import our data, we need to type our command. However, we also need a section because we are very methodical. So you remember where sections are. They're up here, table of contents next to files. So you do want to put a section in. So I reversed it here. No problem at all. I'm just going to use my little arrow to move this cell up. All right, so we want import data. Import data, and we are going to bold that if you want. You don't have to. All right, so I see in the chat here. Okay. So you got some red when running your code, Mackie. You want to look at the code on my screen and just verify that you've got, the period in the right spot, that you've got, the reference to the library, that's correct, and so on. Remember, these are from statements, and if you put import, that's going to be a problem. Maybe there could be a whole host of reasons as to why you got red. So if anyone did get an error when they tried to import their libraries, just verify that you've got from in the beginning here. You don't want import, right? On lines 3 and 4 here. This is MLXTEND. So that's an L, not a 1 or whatever. Maybe that sometimes. And there is a period in between MLX10, it's MLX10.frequent underscore patterns. So just verify you've got your underscores, your period where they belong, and make sure that line 3 and 4, like I have here, is from. Oh, cool. All right, good, good. Excellent. Yeah, it's usually one character away from success, right? It's the little things in life that, drive us crazy. So once you've typed in the command to import your data, and you import your data, you will see the data. I want to make sure everyone gets to this point because I want to discuss our little data set preview that we see here. Remember, we're only seeing the first 5 rows because that's what the head command does. It gives us the first 5 so we can kind of look at our data and say, does it look reasonable? Is it weird? Is it got problems? Do we have characters that make no sense? And those kinds of things. So has anyone not imported their data? Maybe that's the best way to ask the question. Everyone's good?
Yeah.
All right, okay. So the question becomes, all right, Mackie says almost, okay. Question becomes, what values would give us that uniqueness we were talking about? And I'm talking transaction uniqueness.
The member number?
You got it. You got it. Member number. So that determines my basket versus your basket, right? If you think of it in that term, my basket versus your basket. It might be a member number, and it might be a customer number. It also might be an order number. Okay, so think of an order that you might place online as order whatever the number is, and you had items in your cart and you purchased, you shopped and you purchased. So that order number gives you that cart level uniqueness, that basket uniqueness. Okay. So then the question becomes, well, did that member purchase on the same date other items, in 2 different times in a day? We're not going to worry about that because that's highly unusual behavior, and we're going to rule out that later on. So we don't need to worry about that. Okay, so Mackie asked, would I please go over how to import the data? Okay, so it's probably the file that you're asking. So you're going to go over to the files icon on the left, and you should see the word sample underscore data. You're simply going to click on the plus, or the plus sign, the icon with an arrow, but the one with the white page, not the one with the black folder. You're going to click on this one, and you're going to import the CSV file. I'm assuming that's what you meant. Okay, so uniqueness is using the member number. Does everyone understand that? Is anyone confused on that part? So the first thing you're going to look for when you look at the data set that I provide you, or that I provided you for homework, is what gives me that uniqueness? What column? Okay. First thing you want to look at. If you have that and you've got items that purportedly are in that unique basket, you're good to go, right? It is ideal to have the date. Why? Why do you think the date would be important?
To see if there's any fluctuations in purchases.
So by having the date, we know that customer A on that date with their basket combined these items, right? So date is very important because that's another way of determining a basket on a given day. That's very important, right? Because let's say everybody shops, you know, a couple times a week and they put things in their basket. Well, the only way we can differentiate is to have that date. Very important. Otherwise, you're going to be seeing frequency per the member and not the transaction, which is date specific. So my basket on a given date with me as a customer is the basket we're talking about, not everybody's basket over time. It's combining. Each time I combine, right? And they combine, and she combines, and they combine, right? So that's what's important. Okay. Okay. So Mackie, you got reds when you imported your data. So did you import the CSV file? And I'm looking at chat on the other window. All right. Can you check your syntax just to make sure that your syntax is correct here, and also that you have it in the correct location? So remember, if you don't see, if you see something other than what you see on my screen, you're probably in the wrong spot in Google Drive. So if I go up a level, and I'm just going to show you really quick, we have a content folder, right? It needs to be in the content folder, not the sample data folder, if that makes sense. So if you're up a level, you need to make sure that your data goes into content. So you need to open content. So it should look, you know, like it's opened. And this way, you know that this is under this. So see, if I expand sample data, groceries is not part of that. It is part of content. Did you get it? Hopefully. Well, it could be, it is possible that it's in both, and that's okay. This code that this command is looking for it in content. So it should run now. If it's in both, you may have put it in both places because you were clicking really fast or something. Maybe you drug it into it, which is fine. As long as it's in the content folder, you should be okay. All right. Our next step is to add a new section. Oh, before we do that, I'm sorry, I got sidetracked. So again, looking at our data. Okay, are you able to share your screen, Mackie? And I'm assuming, are you in the classroom online or are you in the classroom? You're using two computers. Okay. So I'm going to assume you're on Zoom. Are you able to share your screen so we can see what you're looking at? I'll stop sharing my screen. Are you able to unmute?
I am, but hi everyone. But because I don't have Zoom in the other computer where I'm doing my coding,
Okay.
I was trying to get into the meeting, but I don't have the meeting ID on this other computer. I'll have to go to Open Hub. What's the meeting ID so I could
Well,
type
I can
it?
share the link with you.
Yes, what is that? Could you
Okay.
send it to the chat, please?
That's where I was going to put it. Yeah.
Okay. Let's see. I just need the ID. It's just sending me back to log in.
Mikey, ID is everything what follows Zoom. Just
Yes,
copy the last,
the numbers.
the numbers.
Oh, okay. You know what, guys? I'm sorry. It says unable to join. Oh, I missed one. I missed the two. Hold on. Here we go.
All right.
That's me again. So okay.
Yeah, I
let me
know. I just let
share-
you in.
uh, share screen.
Okay,
So
I see the problem already.
you already
Oh, yes. You have CVS and you have a lowercase g for groceries.
here, right? Oh, here.
It's supposed to be CSV, and the file name is uppercase G ROCERIES dot CSV.
So right here, right? The
That's an
groceries.
uppercase G, and then the file extension has to be CSV, not CVS.
Yeah, I changed that.
No, you didn't. I'm looking right at it on the screen.
CSV,
The
right?
file extension.
Oh, okay. I'm sorry.
CVS pharmacy, but not.
Yes.
Right?
Yep.
There
you
we
go.
go.
All right.
Okay, so I got it, right?
Excellent. Okay. We're good to go. I'm going to now.
Thank you.
You're welcome. So now I'm going to go back to where we're at here. So I really have a quick question. So in looking at this data set, we know there's uniqueness. We can determine that. What questions, and just looking at these 5 records, what questions do you have? In other words, are you wondering, well, why is the date broken out into month, day, and day of week? Does that come across your mind? And you may be wondering, someone has their hand raised.
I don't understand what validity this would have because it's all different months and different people. So what?
There's a huge data set. There's almost 50,000 records. And so what you're seeing is only 5 records of the data set.
Right. But
so you're assuming there's only a few months, but there's a lot more.
Can we not see more of it?
We can. Oh, sure. But with the command that we gave it on line 2 is the head command, which only shows 5 records.
Oh.
So I can tell you that the data set lends itself to the analysis because it's a normed data set, right? So when we're looking at it, we're not conceptualizing it in terms of month, day, or day of week. In fact, it's not even relevant at this point in the analysis. What's relevant is what item sets are purchased, what things are purchased together. Once we determine that, then we'll look at day of the week, the month, and so on. Does that make sense? So right now we're looking at association between products. Now, if you wanted to see more of this, inside your head command, you could type any number. So you could say 100 and rerun it and see 100 of them and see more data. The problem is you're only going to see so much because in your window, it's not designed to show you a full dump of the data. You would have looked at the data in the CSV format before. You would have eyeballed it. If you're looking at that granularity, that's kind of a different exercise. You would be looking at descriptive analysis and not what we're doing. We're doing market basket. So we know our data set based on our descriptive analysis we've already done, quote unquote, that the data set has enough richness that we will be able to do the market basket. Does that make sense?
may I ask a question
Sure.
related to that?
Well,
Real
yes,
quick.
and then I'll answer Connor's question. Absolutely.
Oh, okay. I didn't see Connor's question.
That's okay.
Oh, okay. Would it be relevant as far as like if I'm analyzing this data and it so happened that some of the dates and months fall into holiday or some sort of a specialist day, Black
Yes.
Friday,
Yes.
coming up. So
yeah,
my data will have to be analyzed considering these factors, correct? Is that what
okay. The way it works right now at this moment, we're not focused on seasonality, right? Seasonality is looking at holidays and unusual patterns based on season, which
Mm,
could be attributed to holidays and other things. So what we're looking at tonight is simply associations between products in a basket. Once you do your market basket analysis, you can then go on to other types of analyses that look at time series. It looks at seasonality. It looks at monthly patterns and temporal patterns, which a time series analysis would be used to do, month to month, year over year, and things of that nature. Right now, we're looking just to see who puts what items in their basket and combines them. So this data set could be utilized for a whole host of different algorithms. Tonight we're just doing the one, but it's not to say that this data set doesn't have additional richness that would allow us to do other analyses. Most definitely. Most definitely. Typically, what you would do is you would run them separately, however. You would do the market basket analysis, then you would set up a new notebook and do the next one and the next one, right? You want to keep things, when you're learning, you want to keep it separate. Does that make sense?
it does to me. Thank you.
Okay. All right. So Connor asked the question, is there 3 separate columns? Let me just, come on, computer, for the dates, because the date time is not usable. So the date, all right, so we don't have date time. That has not been applied. But if we did have date time, Um, notice we have just a date. Now the date is formatted in a different way than we're used to. That's fine. It's still a date, but there's no timestamp, right? Timestamp is typically not relevant in a market basket analysis because we're concerned about the basket, not the time. However, there may be cases where time is relevant. Okay. And that goes to things like peak store hours, right? When is our peak time during the day when people are shopping, right? That's a different aspect. So we don't have any time in here. And if you're doing market basket analysis, you typically don't want date time. So you would strip off the time factor. Okay. The data set I provided for homework, I actually did that for you. It's a global online data set. It's huge. And I said, why torture you guys? I'll do it for you. So I got rid of the date time. It's just the date, no time.
Thank you.
Yes, yes. But what they did do here, and what you want to consider doing, is to split out the month, the day, and the day of the week, because month and day of the week and year are all things that you will, after you run this analysis, say, are there any patterns based on year, based on month, based on day of the week? And when it comes to year, then you start looking at seasonality type patterns. So why not split it out in the beginning and get that data set ready to rock and roll so you can go from different types of analyses without having to do data cleaning and data pre-processing. So it's a great data set because it allows you to do a multitude of analyses without having to tweak the data set in the middle. Okay. Does that answer your question, Connor? I hope. Excellent, excellent. Good, good. All right. So that's that. Now we are going to do some data pre-processing, some limited data pre-processing to show you how it's done. So we're going to add a new section underneath our little data frame that we brought in, okay? And we're going to call it data pre-processing because that's what we are doing. So pre-processing. Let me get it right here. And I'm going to make that bold. And if I could scroll or click, I'd be great. My trackball decided to go crazy. And I'm going to bring down a code cell. Now, this next chunk of code, I'm going to ask you to type because it's important. If you type the code, you'll recognize when you create errors. Not to say that you'll create errors, but this is going to be utilized for grouping our items that have the same member number and date. Remember that unique aspect? What determines a unique basket? The member number or customer number and the date. Okay, so that's what we're actually creating. And I, of course, will wait till everyone has it typed. This is actually concatenating, combining two columns into one to create a column called single transaction. It's also using our date value as a unique value and taking it from what it is and making it a string in the new column. So we're not impacting the date in its column that it is. We're putting it in another column and we're saying now you're a string, because we're just going to use those values to make unique IDs for each transaction. Now, our next step, once you're done with this, and I'm not rushing you, we're setting it up so that we can analyze each single transaction. It'll make it easier for us to do that. And that's why we've grouped those items. The other thing to think about is how are we going to determine that one or more items are on a given order? We have to have uniqueness.
What order is this in? Because I don't see any sequence.
It's not in any particular order. It's highly likely that it is
It's not in date order. It's
not. At this point, it's not, and it doesn't need to be, because for our purposes, we're actually going to put it in the order it needs to be once we run our algorithm. So the order is arbitrary at this point. What we're doing is we're actually creating a single transaction, which is a basket. We're then going to pivot our data so that order does matter based on the single transaction. And then within that, we're going to see all of the products and how many times they were purchased. So in the next few steps we're doing, we will be ordering things in a way that every transaction will get ordered, and you'll start to see multiple items on a given transaction. Does that make sense? So you'll start to see patterns as we flip the data around. Right now, the data is kind of in a state that doesn't really help us much. That's a great question, though. Because you're probably wondering, well, how can we use it like this? We really can't. That's why we have to do additional work to it. How is everybody doing with that command? Did anyone not finished or needs more time? Okay, if you got reds, you want to double check your code against what I have here. There's single quotes here, there's underscores, there's pluses, there's a lot of stuff here. So just verify that everything that you've typed is identical to what you see on the screen here. Excellent. Thank you, Janine. Janine's good to go. Yay. Yay. Success. When code runs, it's great. When it doesn't, it's not so great. So what we just did while people are still getting this code working is we did feature engineering. Believe it or not, you were an engineer just now. We added a column, and the column we added was this right here, single transaction. We said we want a new column, and it's going to be equal to the member number as a string plus an underscore plus the date as a string. And you can see what it did is it just combined the first two columns together. That's concatenation. And what we did is separated it with an underscore because we want, you know, to have no spaces in our values for this purpose. So you were a feature engineer tonight. You concatenated. I mean, you're pretty much rock stars in my book. All right, how are we doing? Is anyone still trying to get their code to work? Okay. Mackie's looking it over. If anyone else is still having problems, just double check that you have everything, you know, case matters, as we know, underscores and apostrophes and all that good stuff matters. Python's very specific, very persnickety. It wants what it wants. It's not forgiving. In a way, that's a good thing because we don't want it to, you know, take over and say, I'm boss and you can throw anything at me and I'll do whatever I want. Then the computer rules the world. And that's not good.
Quick question.
Yes.
So like this data set that we're using, was it a particular store that we got it from or like
It's a fictitious store. So that's a great question. Yep. So it's a fictitious store. It's a data set that's out there that's provided for data scientists to practice with and such. So it's not from a particular store. However, the data set you'll be using for homework is from an online store, a global online store. Yeah. So now what's kind of nice though is you can kind of, the good thing about this data set is it's a real one. It's got a lot of data in it. You know, it was designed for really teaching, you know?
yeah, thank you.
Yep. Yep. All right. Is anyone else still not stuck? Mackie, are you still okay? Are you still looking it over? Excuse me. Okay. Okay. All right. So the next step will be to create a crosstab. Now, this is a pivot table in Python. And what we're going to do, just so you understand, is we're going to take single transaction and we're going to move it over to the left side. All right, so crosstab is, changing our columns around. We're going to put the item description next to that. So that's what we're looking at, a cross tabulation. Now, what you're about to see, we're creating a new data frame. Notice it's called DF2. We don't want to impact our original data frame. So we're creating a new data frame, and it's going to look totally different than what we had. Hence the pivot table, AKA crosstab. And I'm just going to scroll up. Now, this is called a wide data set. I'm not going to scroll over yet because I know you're typing. When everyone's done, I'm going to explain the difference between what we had before, which was tall. This is wide, and you can see by my scroll bar, well, number one, I have now 167 columns. Those are all the items, okay? And if the item was purchased in a single transaction, we get a 1. If not, it's a 0. That's how we're able to determine what was purchased on which transaction. Crosstabs are very valuable in Python and any, database, everything, crosstabs. Anytime you do a pivot table or a cross tabulation, you're able to look at your data differently. Mind you, we only have the first 5 rows, okay?
Are these all the columns in the data set?
No,
Well, there's
these
a
are not.
dot in the middle. I see. Yeah.
You're right. These are not all the columns. So these, you've got your products at the top, right? So you've got a dot here, which means we're not seeing all the rows, we're not seeing all the columns, right? Because it's such a wide format, right? It just goes and goes and goes. So again, the idea is you're not supposed to look at the data this way. You're analyzing it and drilling down, and it's market basket analysis is not eyeballing the data. It's letting the algorithm do the work for you. So
Okay.
yes, that's why it doesn't matter if we can't see. We're not supposed to be seeing. We have a little algorithm that's going to say, here you go. This is what you want to see. Don't tire your eyes over the little, stuff that you can't see.
Right. Our biases start as soon as we
That's
start
correct.
looking at it.
Excellent. And I'm so glad you mentioned that. That is essential. The fact that you said that makes me happy, because you never want to make inferences on what you can see versus what you can't see. And you don't want to be frustrated. That's why when you choose an algorithm, it has a very specific purpose. And it takes time to get your data set in a format that will align well with the algorithm. That's why we prep our data to get it in a, just like we did it for the machine learning model, we're doing the same thing for our a priori algorithm. Every algorithm has a requirement so that when we ingest this data, or the algorithm ingests the data, and it runs its course, it'll then give us it'll get rid of the weeds and give us the good stuff that we're looking for. So, and eyeballing the data isn't going to allow us to make inferences about statistical significance. The data set's too big. So that's the other piece of it. Even though it's, only 5 rows at this point, we know the data set is huge, and now it's wide. So not only is it deep, but it's now wide, and you wouldn't want to stare at that. I mean, I like looking at data patterns, but after a while, your eyes get really tired and you can't make a semblance. All right, is anyone still trying to create this cross tabulation? Again, it is a wide data set. It is wide because it's got 167 columns. So traditionally, and in the last several classes, we've worked with data sets that were not wide. They were typical, right? They were more deep than wide. Now we've done the inverse and we said, we just, we're only going to have, 167 columns, and then we're looking at 5 rows because we have this command right here. Naturally, we could expand it out to 100, but we're only going to see so many of them because the data frame will only show so many. Okay. That's correct, Mackie. If you try to run it, it will not work because your prior code is not working. That's correct. Yeah. So in scrolling over, you might see a few ones here or there. So for example, here we have whole milk, there's a 1. Whole milk, there's a 1, and yogurt, there's a 1. So we see there's a lot of zeros. Now, the idea here is that you're going to see a lot of zeros, okay? And that's okay. There's over 100 columns, like I said, and while most people only shop for 2 to 3 items, we know that just based on the domain. Our data is looking very sparse, lots of zeros, and it looks almost like it's kind of a garbage data set, right? But it's not. It's very rich. So anyone else stuck on this? Can I scroll past this and go to the next step? Hopefully everyone's good. Okay. I'm going to assume you're good. So since we know that there's a lot of zeros, which is to be expected, remember, not everybody buys every product in the store in every transaction. Can you imagine if we did? The stores would love us. And they'd say, no coupons for you because you're too frequent of a shopper. You can afford it and we don't care. We want your money. No. What we're going to do is create a function and run that function so that what it does is if the item frequency is greater than 0, give it a 1. And basically apply it to our data so that we will see the data in a different way. Now, let me show you the function. It's a very simple function. It's going to encode the item frequency for us. We're going to start out with 0 because we assume nothing, right? Res is going to be that which we want to take care of, deal with the zeros that we see, tons of zeros. If the item frequency is greater than 0, res should be 1. Otherwise, return res as nada. So just make it a 1 if it's greater than 0. Okay, and we're going to apply that to our df2 data frame. Okay. Now you're not going to see anything as a result, so you'll see nothing, and that's fine. We just created a function, and we created a variable called basket input. So we're getting our data ready for the market basket process. We're getting our data ready for, putting it into the market basket analysis. So one thing that hopefully has jumped out at you is when you start turning your data in different directions, you start seeing different patterns. So lots of zeros. You might think there's nothing there. There is stuff there, but it's how you're looking at the data. And you don't want to like introduce bias like Walker said and think, well, this is not good, or this, you want to avoid those types of oversimplifications. You know what I'm saying? By the way, functions I know we've done, and I'm sure you might have done some functions in Python class. These are very valuable because once you have that function, you could call it again. If you have, a file of functions at your, like a toolkit, you could actually import that file and always use your functions that you create. Just saying. But for now, we have a function, and we're going to utilize it. All right, how's everybody doing?
Okay.
Yay! All right, good. Now, what we're going to do is we are going to go on to the next step. Now, one of the things to think about is we know that any item that was purchased is going to have a 1. If it wasn't purchased, it's a 0. And we're looking to determine frequency. So just off the top of your head, how would we determine frequency? What formula would we use? Like if you were doing this in Excel. What do you think? If we're counting ones and zeros, oh, I gave it away. Oh, bad girl, bad girl. Okay. Okay, so Mackie says an array. Well, that would not be a formula, like a mathematical formula. So let's say we have a data set, we've got ones and we've got zeros, and our goal is to count the ones because they were in the basket, right? What type of formula, like if you were doing this in Excel, which by the way, you can do it in Excel, what type of formula would you be using?
Just add the ones.
I'm sorry?
Would you just add the ones? For
You would, well, what you would do is add the ones, right? But you would want to get a count for each item, right? So you're counting the ones and you're adding them together, right? So they kind of work together. And this is a case where mentally you want to think about it. Am I summing the ones? Am I counting? So yes, so you would want to count the ones. So for each time I see a 1, count it. And then the sum is going to add it up, right? So you have a running total, which is your sum. So I'm counting the ones and doing a running total. So you're doing 2 things at once, basically, okay? All right, so now what we want to do is we want to determine the average number of items per day per member. Now, why do you think that matters? Why do you think that matters? If I do the average amount of items per member, what is that telling me?
Whether they're a family,
What's that?
if they're a family or if they're just a single person.
Okay, so if I'm counting the average number of items per day per member, it's not necessarily the case that I can say that they have a family or not, because I'm looking at the average number of items per day. I could make that inference, but I'd want to be really careful, right? It could be that I'm buying for, a food pantry, right? So I don't really know if it's tied to the household's purchasing behavior. But I know that they purchased a lot of items. And the goal is, since this is Market Basket, is any transactions that only have 1 item, we can't use in the Market Basket. Does that make sense for everybody? We have to have at least a pair for us to create an association between 2 items. So if we have one-offs where they went in and just bought shampoo or they just bought bread, we can't count them. Does that make sense? So we're looking at an average to kind of see where we're at, and then we're going to weed out data that we can't use for Market Basket. Remember, the goal of Market Basket is association between, okay? Association between.
Would it be that you want to use more reliable numbers? So you use the average of,
Actually, no. If you're looking at association between, items, the average has nothing to do with it. This is for our own purpose to see how rich of a data set do we have? Do we have high averages, low averages, because our goal in the next step will be to weed out any transactions that only had greater than one. For this, we're just looking at members in general. So this is not necessary for the market basket analysis.
So this is more like data cleaning
Nope.
then?
Nope.
No?
We didn't clean any data. What we're looking at is on average, how many items do they purchase a day, each person?
Okay.
Yes. So again, we're looking at, remember before I made the statement that on average, members buy 2 to 3 items. Remember I said that? I knew that because I had run this prior. Okay. If we see a lot of averages of 1, we know there's a lot of data we can't use. Okay. I hope that makes sense. So remember, a unique basket is the member number and the date. We need a high count on our item description. Because if that basket on a given date only has 1 item, we can't use it in our market basket analysis. Does that make sense?
Yes.
Yes.
All right. So right now, just looking at these 5 records, I know every single one of these I can include. Why? Because I have 3, 4, 2, 1, and 1. So I'm grouping it by that. And I can see basically that, I've got a lot of data that I can use. I hope that makes sense. Is that so? If we're looking to associate bread and milk and we have no milk, we can't associate them, right? We only have bread. Like if they only purchase 1 item, we can't associate it with another item in that basket because there was no item in the basket. It makes perfect sense, doesn't it? Like mud, doesn't it? Like mud, right? Like
Okay,
mud.
Anita.
All right, everyone, does everyone have that code done? Are you good?
Yeah.
Okay, so one thing I want to show you is here, you'll notice there's a group by function, and you can see we did division. You do division when you want to do a group by. And what we did is we basically determined the average by dividing one thing by another thing. Okay, that's the divisor sign here. All right, and then we grouped it by that. So that is why we did that way. What's also helpful is to view this same data but on a graph. And the graph, it's very simple. We're going to do a simple histogram. I'm going to scroll up just so that you can see. This is going to be helpful. I'm going to wait till you all type it, and then we'll scroll down and look at the data. This will confirm our suspicion that we've got a lot of transactions that have greater than 2, and on average, there's 2 to 3 items in the basket, which is good for our analysis. It's going to be hard for me to show the prior code. I'll do my best. All right, there's the prior code without the comment. Hopefully everyone can see both sets of code.
Could you go up? I just want to take a quick
I'm
picture of
sorry?
it. Could you go up? I just take a quick picture of it. You said there's a comment on top.
Yeah.
Let's cut it.
Yeah, it cut it off because I only have so much screen space.
Yeah, go for it. Go for it. You can move
Okay.
now. Thank you.
Okay.
Sorry.
That's okay. Now this says histogram of item quantities per shopping. It should be shopping basket. But it would get too long. But I hope you understand that. We're looking at each basket and we're looking at the average item quantity. We want to see everybody's average. And actually, I can change that to basket. Maybe that makes it easier to understand. If you already type shopping, don't worry about it. How's everybody doing with this code? Good?
Yes.
Yeah, good.
So do you remember a histogram is used for what kind of data? Categorical? Anyone?
Numerical.
No. Okay, numerical. And specifically what kind of numerical? Continuous, right? Continuous.
Oh, yeah, yeah.
All right. So remember up here, we did averaging, right? And what we're looking at down here is continuous. What bucket do they fall in? Average is 2 to 3. And right here is where our 3 is. So on average, a lot of people have 2s. You can see that there are in the 2 bucket, right? There's a real tall bar here. In fact, we've got 10,000 people that have 2 items. We can use their data because they've got 2 items in their basket. And then we have some people that have 3 items in their basket. And we have some people that have 4 or 5 items. And then it trickles down. Okay. What we will do in a second is we will analyze our data. What we have here in our data set, and what you may not have realized up here, is we basically said, give us a data set where there are more than 2 or more. That's what this function was for. Okay, 2 or more, because that's what's required for our market basket analysis. And now we have a kind of an idea of how many records are capable of being put in. And we've got a lot of good records. This is actually good because this will give us enough data so that when we render significant findings, it'll mean something and not just 5 people, right? So this is a good thing. This allows us to see that we're on the right track, that our subset of data that we've come up with is we have enough records that we will be able to make some generalizations. Does that make sense to everybody? And I know it's late and you're probably tired, but does that hopefully make sense?
Yes.
Yeah.
And
Yes.
just so we know, this is per single date. This does not.
A basket is on a date. You got it. Yep.
Right. Okay.
So
it's not an average.
You got it. This is not an average. That's correct. But what we did above is we created an average to kind of take a peek, right? But we had already run this function, right? But when we look at the data, right, this is looking at which data set, our original data set.
Okay.
Right. So here we basically said, give them ones if they qualify. Here we went back into peak and said, well, let's see if I can determine how many. This ain't going to work. This averaging process is not going to work. It's good data, mind you, but it's not going to really help us see how many records we have that are rich enough to put into the algorithm, right? So this is the attempt, and the whole idea was to show you that yes, this is a good thing, but it's not enough. We need a different way. And that's where we're looking at our data in a different way and plotting it this way. And it actually did that aggregation for us. And now we know that we have enough data to work with to feed our algorithm. Okay.
Okay.
Mhm.
Is this a real data set, or is this like just a like a
This
one to
is
learn
this
on?
is a this is actually a teaching data set.
Okay.
And I apologize, I don't remember, I don't believe it comes from a real store. I think it's hypothetical.
Okay.
Yeah, but it is designed in such a way that it emulates a real scenario. The one that you're doing for homework is a real one. And it's a fantastic one because it's a global data set from an online store. It's global, so you'll see some culture in there, which is kind of cool, kind of fascinating. And that is actually a real one, but it's not from this country. I'll give you a hint, wink, wink. All right, it's not from this country, but it is global, so there might be some in there. There's no differentiation, but when you look at the catalog, the product catalog, it's like I've never seen that here in the States, or maybe I saw it, but it was in a specific version of that. Yeah, that's all
Maybe
right.
Mexico?
Not Mexico, not Mexico, but right. But you will see nuances, and that one is actually a real one, and the data set is quite larger. So what is kind of cool is when you look at the data set, I hope you'll appreciate that data can be scribed in different ways, right? You don't want to always strive to have the data look like I'm used to or what makes sense to me. So for example, you might see column names that seem arbitrary or weird. That's how they describe it. So you have to say, okay, well, that's how they describe it. That means this over here. And I can work with data all over the world because let's face it, it's an online world, a global marketplace. So you have to be open to accepting the data as it is and then framing it in a way that makes sense for you based on your understanding. And it's no different from folks overseas that look at our data. They might look at it, okay, this is how they do it in America, it's this tomato, right? It's that same thing. But as long as you understand what the data purports to show in that column, you can work with it. And that's the fascinating thing about it. We speak the same language. We all go shopping. We all have transactions. We buy different things. As data scientists, we work with this type of data. We know what we need to make this happen. So that's something else I want to just throw out there. All right, so the next exciting thing is to bring down a new code cell because I am actually going to give you now, we're actually at the point we're going to build our a priori or a priori algorithm. And this is the fun stuff, okay? What I want you to do is type, the code, and then I'm going to describe the code, and then we'll run the code. How's that? So we'll type the code, then we'll describe the code, and then we'll run it. So even I am following my own instructions. I'm not running it, even though I'm dying to run it. So remember, the goal was to create frequent item sets, right? Associations. So we need item sets that are, items that are found together. We're using our column names. We're running the algorithm against the basket input, which was that subset of data that we created, the data that qualifies. Anything greater than 1, meaning 2 or above. And then on line 5, we're going to be applying the association rules and basically viewing the results once everyone gets this typed. So while you're typing that, you'll notice that the majority of the work is getting the data in the format that you need. It's called transforming the data. These 3 lines of code, actually 2 lines of code, and the reveal is the algorithm running. So once you've written your code, you can go ahead and run it. I want to make sure everyone's ran, and then we're going to take a break. And when we come back, I'm going to describe the results and what they mean. Okay.
For some reason, mine is
It-
saying basket input not defined.
Okay,
So-
so that means that you did not run this code right here, that this didn't work properly.
Oh,
Or-
let me try that again.
Yeah.
Thought it did.
I have a silly question.
I'm sorry, go ahead.
Is there a particular reason why you skip a line at some point when you're doing the coding, or is this intentional, or does
Okay,
it
so
matter?
where did I skip a line?
For example, the one that we just typed, number 6, you went down to start writing basket underscore input, blah blah blah.
This
Like
one
there,
here?
yeah.
This is not part of the function. This is the function. So
Oh, okay. So it doesn't matter. You could just
right,
go
right.
down and
But
write.
well, it does matter. There's programming best practices, and what I've
Mm.
done is introduce white space. White space allows me
Mm.
to parse it and look very quickly and say, I have a function, and then I have an application, a call to the function, and assigning that result to a variable. If this was up one level, I might not see that they're separate. So it's just a visual thing to help you see that, okay, they are different things. So if I didn't have line 7, all I would have is a function, but no call to the function.
And I may have a syntax error, so I'm going to look for that because the
Okay, I'm going to
above
scroll.
code did run.
So this ran?
Yes.
Okay. So the thing to look at then here is whether you've got a problem there. Yeah.
Yeah. Okay.
But the fact that basket input was not defined, I would say, do you have the underscore? It's got to be identical as how you defined it above. So underscore, check that.
Mm-hmm. Yeah, no, that's there. That's an interesting thought, though. Let me go up and look. Basket input. Basket input.
So they're the same?
Yeah.
Okay.
I wonder if it's anything else.
Well, no, where you define basket input is literally in that function. It's the variable was assigned after the function. So that's where the assignment happened, but you're using the DF2 data set. If you did not create the DF2 data set, then the basket input would not get defined, would not get created. So, but it would have thrown an error. So does that run properly for you?
Yeah,
Above?
that one up there is fine. Everything else seems to be good. And then yeah, I'll keep looking,
Okay,
or I can
okay.
review next week, or
I'm
the
having the same
video.
issue.
Okay, you're having the same issue?
Mhm.
So again, where this got defined is up here. Oh, went too fast. My scroller is just crazy. Good Lord, have mercy. Right here. So here's the deal. If you did not indent your code, that's a problem. So the indentation is purposeful. This is 8 steps or 8 spaces. This is 4 spaces. So this literally has to be indented exactly as I have it. That is one of the problems that could be. The other part is if you did not use DF2,
Oh, my basket input was on the same indentation as return.
that is a problem. Then you
Okay.
actually did not create your basket input. Yeah.
Okay.
Yes, and this is a case in point. Python works in 4 space increments, and certain things must be indented. And if they're not indented properly, it may actually run part of it, not all of it, and it'll say, "Oh well, no basket input for you," but it doesn't tell you. So now when you go to call basket input, it says, nah, I don't know what that is. So excellent. Did that solve both your problems, hopefully? That's actually a good problem to have because that's a good talking point.
Yes, it was the indentation.
Excellent, excellent. So indentation's important in Python, right? So white space is for visual, so we can see that, yes, we have a function and a call to the function and assignment to the variable, but also the indentation. This matters, this right here, how I indented it. What can I say? This is why typing the code's important. If I were to copy and pasted that, the indentation would not be preserved, and then you would not have realized that this is the nature of the issue. So this is a good thing. So can I scroll down to the other code?
Yes. let me look
Okay,
at that.
cool. All right. So once everyone's able to run this, we are going to take a break, refreshment break, and stretch our legs and what have you. When we come back, I'm going to explain what these mean and then how we would interpret it as a data scientist reporting it back to the company that hired us to do this in the first place. How would we, what insights would we gain? Okay.
Okay. Thank you.
All right. So why don't we take a quick break? I'm going to leave my screen shared. Okay. Let's take a break. Let's go till 7:24 because I want you to stretch, get something to drink, use the restroom if you need to. And we'll come back 7:24 sharp. Okay. All right. I'm going to pause our recording. All right. Okay. Recording is in progress. I did a good thing. I didn't forget. Imagine. All right. So we ran our algorithm and we ran our market basket analysis. And there's 3 metrics we're going to focus on, but I'm going to work from left to right. Our antecedents is the first item. So if I bought milk, did I consequently buy water, bottled water? Okay. So this is that if then. The antecedent is before and this, right? Now, you might also see that there's the other direction, right? So here's bottled water. If I bought bottled water, did I in fact buy milk? And the direction of it matters, okay? So let's look at the first line. The first line, we're going to focus on support, okay? Confidence and lift, because those are the 3 that we talked about. So I'm over here. All right, I'm over here, support, confidence, and lift. So for the first one, would you say that there's a high level of support for milk to water, bottled water, based on what you learned earlier on the PowerPoint? Is that a good number that I've highlighted there or a bad number?
Low.
Bad.
It's very bad. It's so minuscule, we shouldn't even worry about it, right? It's very small. Un poquito, right? Un poquito. Very small. But that doesn't mean we say, oh, the heck with water and milk. We're not looking at that. We're looking at everything. So let's go over to confidence. Confidence is also kind of small, right? Would you say it's 0.05, right? But what we do have a nice number on is lift. Now, who remembers from their notes what lift is? What is lift?
If you buy one, how likely are you to buy the other?
You got it. You got it. So we now see that there's an association. We see that if they buy milk, there's a high association with bottled water, which is good, which is important. Now, there's other metrics here that we haven't talked about. And I don't want to confuse you or confuse the works, but I'm going to give you what I think you can handle at this hour. Zhang's metric, okay, is as you may, you see a minus sign there, right? One is if it's positive, there's an association. If it's negative, there's a dissociation. Okay, but it ranges between -1 and 1. Okay, so this is greater than 0 or less than 0. What would you say?
Less than?
It is less than 0. So that would be what? That would be a dissociation. So what this is saying, because of our lift that we saw, that if I don't buy milk, I probably won't buy bottled water. So it's basically very definitive, okay? It's very definitive. Now, that's all I'm going to say about Zhang because I don't want to confuse you. There's conviction as well, and high conviction basically means that one is dependent on the other. So based on what I just said about Zhang, we have a 0.98 on conviction. So what do you think? Is there a high dependency between them? 0.98?
That seems high.
Uh-huh.
That could be a 1, no?
But if it's a 1, it's perfect. Once you go past 98 to 99 into 1, a 1 of conviction is perfect. In other words, it's
Almost
100% dependence, right? So what we're seeing is an association between them and a dependence between them. Okay. So that's how you would interpret it. Now, I'm not going to get too crazy on conviction and Zhang because I want you to focus when you're doing your analysis for homework. I want you to focus on support, confidence, and lift. And I want you to look at your notes. All right. Based on what we learned, the lift values here are all 0.8 and above. Would you agree? So this is meaningful. Okay. Confidence is not so high, not so good, right? Confidence is not so high, and support is not so high, but the lift is high. And that means that they are dependent on each other pretty much in a very same realm. Why would that be? Well, let's look at the relationship. This is in one direction, this is in the other. So of course they're going to be very similar, right? We would assume that, but it's not always the case. So what this is saying, when you have this sort of quadruple or quadrant here, milk to water, water to milk, okay? If I buy one, I buy the other. If I buy one, I buy the other. If I don't buy one, I'm probably not going to buy the other because of Zhang. It's negative. But notice Zhang is not very strong. That's something I don't want to confuse the works. I would look at lift if I were, focusing on what can I derive from this. The lift is very important because we have it going in both directions. Now, we have milk to vegetables, or I should call them other vegetables, and we have other vegetables to milk. What do you see that's different, if anything? Is the lift the same?
Yeah.
Okay.
Yeah.
It's a respectable lift because it's 0.8 or above, right? What about support? Is it the same?
Yeah.
Yep, it's the same. What about our confidence?
No.
It's
Confidence.
different.
It is different. It is different. So when you're interpreting these things, you want to think about, well, what is confidence? What is lift? What is support? What inferences can I make? And if I see something that's a small result, what if I test the opposite of it? What if I go in the other direction? Now, the software did it for us. So there is no other direction when it comes to, for example, milk and sausage. But guess what? We only have 5 records here. It's very deceiving. It's very deceiving. So what you would want to do is you would want to actually download the entire thing or expand it. So for example, Let me not mouse over. Let's bring in, I don't know, 100 records, or yeah, 100 records, and see what we get that's different. Now I'm running my analysis again, which is not a good thing because it takes time. Now I can see more of it, but I'm not going to see past the fifth row here. I'd have to export it out as a data set. Okay. I'd have to export it out as a data set. The point I'm trying to make is you want to look at the entire thing and look at each line, line by line. You don't want to assume anything. What we can say, and what I can tell you, because I have done that with my data set, I've exported it out as a CSV, is that rolls and milk tend to be bought together. Okay. And again, I would have to look at the, the entire data set, but I've done that. Yogurt and milk are very common as a combination. And pretty much that, that makes sense for us. Here's a weird one. Sausages and milk is common in this data set. And soda and vegetables. Wow. Soda and vegetables. Now, you can't deduce that from just looking at it like this. You would literally have to export this out as a CSV file to be able to do that. So does that make sense to everybody?
Yes, and I feel like we've done this in other
Classes.
analysis.
Oh, Walker, you get the prize. Yes, and that's why I'm not showing you how to do it.
So you're not going to tell us how
Oh
to find, like, the
no.
most
Au contraire, for your
common ones?
homework, for your homework, you're going to have to export out as a CSV and give me your insights in the conclusion paragraph. So I just gave you the conclusion paragraph, which, by the way, I'm going to copy and paste it here. You don't have to type it, but you know how our conclusion goes. We put in a conclusion, right? And we put our findings. You're going to be, you're going to be doing that for homework. If I could type, I'd be dangerous. All right. And then you're going to put a text cell and you're going to say, this is what I found. All right. And that's not good. Let's get this on separate lines. Just like that. Okay. So this is what I found when I did the analysis of the whole thing. The items that are frequently bought together are these things. And I would have never guessed. I mean, maybe yogurt and milk, maybe rolls and milk, but sausage and milk, ew. And soda and vegetables, wow. So it defies our biases, our norm, what we believe to be true. So one reason for this, and we have to be very careful, is these are product combinations that are popular. Okay, they're frequently bought together, hence they are popular. We don't know the reason why, and we don't want to make inferences. What we can say is one reason for this could be that the grocery store ran a promotion on these items together, or they displayed them in the same, line of sight to improve sales. We do not know, but we would go to the person that hired us and have these discussions, and they might say, oh yeah, we just did a promotion, a campaign, and then they might say, well, we only did that within the last month. So then you have a temporal problem. You need to look at what happened in the last month. So you would narrow down your data set, right? So you would come up here, you would narrow down your data set, go all the way up above, rerun your analysis, and look at last month's data only. Okay. To see if there's an association between the marketing campaign and what we're seeing.
Are you telling me with all these fancy formulas, we can't just type something in and it'll tell us we have to export a CSV? And
no, you are a data scientist. You know that if I need to see this data set in a different form and I want to work with it offline outside of this environment, I need to export it because you have been trained thusly.
That one slipped my mind. Okay.
But the fact that you remembered that you did it before that is kudos worthy. There's an association between what I said and what you remember, and that's a good day, right? So when you don't remember what you said or the other person said, and you don't know what day it is, that it's a bad day. See, so things are good, Walker. Everything's all good. All right. So that being said, if you're doing the homework and you're struggling, that's where office hours is essential. All right. So the homework, I'm going to stop sharing this screen and go to the homework quickly and open it up for you and share that quick because I know they close soon. Let me share this quick. All right. So our homework is there's a data set. It's the global online data set. You'll see it on OpenHub. You're going to perform a market basket analysis based on the code that we did in class. And you are going to look at what we did in class and the columns that we use for the analysis and look at the data set that is on OpenHub and say, okay, what columns do I need? And you're going to think before you do, right? Very important. You want to use comments as you go. In your conclusion section, you're going to write the conclusion, discuss the insights, and anything that you could provide to the online retail store. And then write down, of course, any questions that you have and go to office hours or post them on Slack. Okay. So any questions about the homework? This is on OpenHub. And the instructions are there and so on and so forth. What do you think? Can I do it? Right? Big question. Can I do it? You guys have done superb tonight. You have, you know, it's a lot of information. So don't, if you're tired, you know, that's okay. You're normal. Just think of it. I'm normal. I'm tired. I'm normal, but I'm excited about the potential of what I can do with data analysis, right? And that's a good place to be. You're not going to learn this all in one day. That's why sitting in the chair and coding, doing what you need to do is going to get you to the next step. All right. Any questions before we wrap up?
I just
Yes.
had one quick technical question. How is it that when we post the collab notebook and I look at other people's, I can see it with their data? Doesn't that data go, isn't it ephemeral? Or is it
Say
just
that again.
maybe I was
It cut
looking at
out there,
someone's?
Walker. It cut out.
Oh,
Say
I'm
that
sorry.
again.
So when we post, you know how our CSVs will like eventually
Yes.
vanish, right?
You're not rerunning their code. You're looking at a snapshot. So that snapshot stays.
Oh.
Yeah. That's a
Okay,
great
got it.
question though. That's great. So you're not rerunning it. It's kind of like it's kind of like a snapshot in time. So if your
Okay.
data did change, you'd have to re-upload it. That's a great question.
Okay, got it.
Great question. Yep. Yep. All right. Any other questions? You guys did wonderful. Again, reach out if you're interested in the internship. I believe Yulia gave you instructions on what you need to do. There's posts on Slack you want to check because there was some posts there. All right. Okay. I'm going to
Thank
say
you.
you're very welcome. I will post the recording link shortly once it processes and such. And I look forward to seeing you next week. Okay. Take care, everybody.
Thank
Sounds good.
you.
You're
too.
welcome. You're welcome.
Bye.
Take care. Bye-bye. Good night.
Good
Bye-bye,
night.
everyone. Good night.
Right.
Good night.